Okay, let's talk about the pH scale. And we gave a little bit of information about that yesterday in your video. Let's take a look at it again. The pH scale is a scale that runs from 0, oops, let me put it in red, 0 all the way to 14. In the middle of the pH scale, we have a 7, and that means neutral. That would be for pure water. So the 0 to 6 end of the pH scale is the acidic end. Now, the smaller the number, the more acidic it is. Lemons are around here, and battery acid really is over there. The more basic end goes from 8 to 14. So the larger the number, the more basic and more alkaline it is. And like over here, we have a very strong base in NaOH, it's sodium hydroxide. Okay, so that is the more basic end from 8 all the way to 14. So what does pH stand for? It means the power of hydrogen. What it does is it measures the concentration of hydrogen ions in solution, and the way it looks is we take the H and put up the plus sign with it. That shows you hydrogen ions, and that we put that in brackets. It's really a logarithmic scale, but don't worry about that kind of a thing. Let's go ahead and learn how to calculate pH a bit. The pH of a solution is the negative of the exponent of the concentration of the hydrogen ions. Well, what does that mean? If we have a hydrogen ion concentration of 10 to the minus 6 molar, what that is 1 times 10 to the minus 6 molar, then we take the negative of the exponent, and the exponent here is the minus 6. The negative of the negative is going to be 6. The pH will be 6 for that. So we have to understand that one thing's for sure, is that pH plus pOH and has to equal a total of 14. So if the pH of a solution equals 6, then the pOH of a solution is going to equal 8, because they both have to add up, when they add them together, they have to add up to 14. But going back to calculating the pH of, or the hydrogen ion concentration, let's take a look at this one right here. So if the pH is 12, then the hydrogen ion concentration is going to be 1 times 10 to the minus 12 molar. Okay, we'll show you how to calculate that in a little bit, but let's go over here. Again, if you can determine the pH, then you can always determine the pOH, because both of them have to add up to 14. And therefore, if the pH happens to be 12 of a solution, then the pOH is going to equal 2. So there it is again, just showing you the pH plus pOH is going to have to equal 14. Now here's another problem. If the hydrogen ion concentration, the hydroxide ion concentration of a solution is 1 times 10 to the minus 2 molar, then what we do is then what we can say is that the pOH is going to equal 12. Or 2, 2. Get my math right. It's going to equal 2. So if the pOH is going to equal 2, and the pOH and the pH have to equal to 14, add up to 14, then pH is going to equal 12, because they both have to add up to 14. Okay. Now, we do calculate pH value on a calculator using the logarithmic function, the log button. So if you have a hydrogen ion concentration, okay, and you want to find out what the pH of that is going to be, then what you're going to do is you're going to take the negative log of that hydrogen ion concentration. That's an easy thing to do. So in order, what you would do, for example, let's say if you had a hydrogen ion concentration of 1 times 10 to the minus 4 molar, and you wanted to find a pH for that, what you would do is you would take the negative log, and you can do it this way if you want to. You have to put in parentheses. You can put 1 times 10 to the minus 4, and close it out, and that's going to equal 4. Okay? So if that's the pH of a solution, then the pOH is going to equal 10 because they both have to add up to 14. Okay? Same thing goes with the hydroxide ion concentration. The same formula runs for it. So to find the pH, you must take the negative log of the hydrogen ion concentration. To find the pOH, you must take the negative log of the hydroxide ion concentration. Now, if you were given the pH and you had to find the hydrogen ion concentration, you have to do what's called take the antilog of the pH. And for the OH concentration, you would have to take the antilog of the pOH, which is really not that hard to do. It just sounds complicated. In fact, just a few buttons on your calculator. You don't have to do any other math besides that. So let's take a look here. Say we have a hydronium ion, which was 10 to the minus 5 molar, okay? And what we'd have to do is calculate the pH for that. Well, we set it up like this. The negative log of 1 times 10 to the minus 5 will equal 5. And that's the pH of that solution, 5. However, we can find the pOH too, because 14 minus 5 equals 9, and that would be the pOH for that solution. Because remember, the pOH and the pH both have to add up to 14. Same thing with the hydroxide ion concentration. If you were given a concentration of 1 times 10 to the minus 4 molar, then you could take the negative log of that, find the pOH, and if the pOH equals 4, then the pH is going to equal 10 because they all have to add up to a total of 14. Okay, so we're not going to use decimals in our math, and that will not be on our skill sheet either. We're going to keep it with the whole numbers. So what we're going to do is let you work on a few problems on your skill sheet. And I'm going to tell you exactly what they are when you get done with this video. Okay? Let's see if this works.